Hello. So I was hoping I would be back today. Unfortunately, I cannot. After Wednesday, I knew that we needed to go back and review sections 1.1, 1.2, and 1.3. So I put together these worksheets. Unfortunately, I was not there to make the copies for you. I know that you looked at these yesterday in Envision, but I wanted you to go ahead and go through them again with me. So we'll look at 1.1. This was where we learned about all of our transformations. Okay? So it tells you that the linear, quadratic, and absolute value functions can be graphed using the key features that the equation identifies. Key features can be labeled using either set builder notation or interval notation. Remember that we will be using interval notation. Interval notation represents your set of real numbers by pair of values. The parentheses are used when the points are not included, and brackets are used for when a boundary point is included. So number 1 says use the function f of x equals x squared minus 16. Identify the key features that are listed in the table for the graph. Label the graph with the key features. So remember that our parent function for this is going to be f of x equals x squared. F of x equals x squared minus 16 has a vertical translation down 16 units. So first, the domain. Remember that the domain are our x values. What can we plug into this function? We can look at the graph. Starting out here, way out here, I see I have all of my negative values, and it goes all the way out to my positive values. So our domain is negative infinity to infinity. And remember that anytime that we use infinity, it's always parentheses. The range, those are the y values. What are we going to get back? Okay. The smallest y value on the graph is our y-intercept, where it went down at negative 16. So this is the point 0, negative 16. So my range is bracket negative 16 to infinity. The minimum value, that is the y value at your vertex or the lowest point on the graph. So again, that's that negative 16. So our minimum value is negative 16. The x-intercept, that's where it crosses the x-axis. We see it crosses twice, one right there and one right there. And so we can either write it as an ordered pair, negative 4 comma 0 and 4 comma 0, or you can just write x equals 4 and x equals negative 4. Either of those are acceptable for an x-intercept. Y-intercept is where it crosses the y-axis. We already know this point, the 0, negative 16. Again, we can write it as the ordered pair, 0, negative 16, or as y equals negative 16. Where is the function positive? Okay, remember, that's where it is above the x-axis. Okay, so right here and right here are my positives. Positives. So the function is positive from negative infinity to negative 4, and then the u for union or and picks back up at 4 to infinity. Function is negative. That's all of this where it's below the x-axis. Okay? So that would be from negative 4 to positive 4. The interval where it is increasing from left to right, so it starts increasing here and up. So this side, all of this is increasing. So the x value that it starts at is 0, and it increases to infinity. So 0 to infinity. Decreasing is everything over here from left to right. My graph is going down, so this is my decreasing. That's from negative infinity to 0. All right, the next one, Cheyenne identified the key features of the function f of x equals x plus 4. This is a line. Remember, y equals mx plus b. Algebra 1, where in our case our slope is 1 and our b or our y-intercept is 4. It said she wrote her answers in the table, find and fix her errors. So she said that her domain was negative infinity to infinity. That's correct. I can plug in anything into that equation. She said her range was also negative infinity to infinity. Again, she could plug in anything and get anything back. She said her x-intercept is at positive 4. Well, that doesn't quite seem right. So if I wanted to graph this to check that, I know that my y-intercept is at 4, and then the slope we said was up 1 over 1. If I keep going up 1 over 1, I'm not going to get an x-intercept, so I need to go down 1 over 1 to find my x-intercept. And that puts us right here at -4. So her x-intercept should have been x equals -4, not +4. Y-intercept, she has 4, that's correct. The function is positive, so again, that's where it's above the x-axis, all of this. -4 infinity, she got that right. Negative, down here, negative infinity to -4. So the only mistake made was the x-intercept. Next one, identify the key features of the function f of x equals absolute value of x minus 3. Okay, so remember that its parent was just absolute value of x. If I looked at my xy table of my parent function, using our -2 up to 2, we would get these values. So now my new one, absolute value of x minus 3, that shifts to the right 3. Remember, it always comes out opposite, so it would have been x plus 3. All of my y values would stay the same. Add 3 to each of these x values. So -2 plus 3 gets us 1, 2, 3, 4, and 5. So then if we wanted to graph that, over 1 up 2, 2, 1, 3, 0. This is the graph that we are looking at. Sorry, I need to draw my graph a little bit better for you so that it's more accurate. There we go. Okay, the domain, the values of the x-axis. Okay. Again, this is what I can plug in for x. Notice that we can plug any number that we want in for our x. So -infinity to infinity. Values of the y-axis. Okay, I'm not going to get anything back that's negative from an absolute value. So my y-axis, okay, my range would be bracket 0 to positive infinity. The minimum value, the lowest point on the graph, that is this point right here. So that is when x equals 3, y equals 0. The x-intercept when y is equal to 0, again, that's right here at 3. The y-intercept when x equals 0. So again, if I plug that in, 0 minus 3, okay, get absolute value of -3, which is 3. The function is positive when it's above the x-axis. It's always above the x-axis on an absolute value, so -infinity to infinity. That takes care of section 1.1 review. So let's go to section 1.2. This is where we learned all of these transformations. Okay. We need to make sure that we are memorizing these. So the very first one, okay, f of x plus k. Remember that k on the outside, it shifts the graph up. It's a vertical translation. If it's an f of x minus k, it's a vertical translation down and shifts the graph down. Horizontals, or when you have it inside parentheses, or absolute value. So f of x plus h, remember that it always comes out opposite. So if it's an x plus h, it goes to the left. F of x minus h goes to the right. The f of negative x, when the negative is inside with the x, It's a reflection across the y-axis. This reverses the sign of the x-coordinate. If it's a negative f of x, so negative on the outside, that's a reflection across the x-axis, which reverses the sign of the y-coordinate. If our a value is inside with the x, it gets multiplied by the x first. That is either a horizontal stretch or compression by the factor a. The graph will move closer to or farther away from the y-axis. If the a is on the outside of the equation, then it's a vertical stretch or compression by the factor of a, and this is where the graph moves closer to or farther from the y-axis. So first we're just going to match each of these following equations with the transformation that occurred from the parent function. So the very first one, f of x plus 4, it's on the outside, so that is a vertical translation up. So this one right here is a. The next one, f of x minus 4, so that is a vertical translation down. So right here is b. F of x plus 4, okay, remember that inside parentheses comes out opposite, so it would come out as a negative 4, which moves horizontal to the left, so this is c. F of x minus 4 would come out as a positive 4, which would be a horizontal translation to the right, so this is d. I have f of negative x inside, okay? If it's inside with the x, that is a reflection across the y-axis, so this is my e. The next one, negative f of x, the negative out front, reflects across the x-axis, so this is f. The next one, we have f of 4 times x, okay? So when it's multiplying by the x before it does anything else, that is a horizontal compression, so this would be g. And then finally, when it's 4 times the entire function, that is the vertical stretch, this would be h. So let's look at this next one. It says that Beth said that g of x equals f of x equals x squared minus 12 is a horizontal translation of f of x equals x squared. Find and fix the errors and write the equation for a horizontal translation. So first thing, she said horizontal translation. This does not represent a horizontal translation. X squared minus 12 is a vertical translation down 12 units. If she wanted to write the equation for a horizontal translation, it would have looked like f of x equals, we need some parentheses, x minus 12 inside parentheses, quantity squared. And next, use the parent function f of x equals x squared to fill in the blanks. F of x equals negative x squared is a what across the x-axis? Anytime we have that negative out front, that is a reflection. This is where it changes the way that the graph opens. B, f of x is blank is a horizontal translation right by 3 units. So if it's going to go right, I need parentheses. So x inside parentheses goes to the right, which means that it was opposite inside parentheses, so minus 3 quantity squared. F of x equals x squared plus 6 is a vertical translation up by, this is a positive 6, so up by 6 units. All right, let's look at the last section that we have covered so far, 1.3, the piecewise defined. And just recall that the piecewise has different rules for different parts or pieces of its domain. In order to evaluate a piecewise function for a given value, find the interval or piece that x belongs to. Find the corresponding definition of the function for that interval. Okay? So example number 1, this is going to be like those first problems on that worksheet that I gave to you the other day, where it asked you to evaluate the function. Okay? So here I only have one function, f of x equals 3 over the domain when x is between negative 5 and negative 2, or x minus 2 when x is between negative 2 and 0. Notice this one, negative 2 is not included, so I will never be plugging negative 2 into this equation. The worksheet that I gave to you for the homework the other day, you had to find which equation, you had like f of x, g of x, and h of x. So first you had to find the correct equation and then look at your domain and figure out, based off of the number they gave you, which one are you plugging it into. So here, solve the piecewise defined functions for the values listed. Use the equations shown for each group. So this first one, they give me f of x equals 3. So they're telling me that this is the equation I'm going to use. The negative 5, x is between negative 5 and negative 2. Okay? What they're telling me is that no matter what x value I plug in, my y value is always 3. This would be a graph of a horizontal line. So these first three are easy because I don't have a variable to plug in. If x is negative 5, my y is 3. If x is negative 4, my y is still 3. If x is negative 3, my y value is still 3. Now this next one, it tells me for x between negative 2 and 0, we're going to plug into this equation, x minus 2. So they want to know, what does y equal when x is negative 2? So plug negative 2 in for x. Negative 2 minus 2, negative 4. Here they want to know, what does y equal when x is negative 1? So plug negative 1 in for x. Negative 1 minus 2, we get negative 3. And finally, if I plug 0 in for x, 0 minus 2, negative 2. Next one, Dion graphed the piecewise defined function. Explain what mistake he made and how he could fix it. So he has 3 parts over here. Notice over here, I only see 2 parts graphed. The first one he has, f of x equals 2. That's just my horizontal line, y equals 2, when my x values are negative 4 to negative 2. Both included closed dots. He has that, this part. So this part is good. Next we go 2x minus 4. When x is between negative 1 and 2, 2 not included. So if I look at my graph, this would have a y-intercept of negative 4, slope up 2 over 1. Here's my y-intercept of 4, up 2 over 1, up 2 over 1. So he's graphed that right. Okay? He started at negative 1, so at negative 1, he's down here. He should have stopped this graph at 2, but notice that he doesn't have a open dot here. He just kept going. So he has graphed the 2x minus 4 with the wrong domain. And then if we look at this function, 3x, that would have had a y-intercept at 0, should have started here, slope of 3. So up 3 over 1, up 3 over 1, up 3 over 1. He doesn't even have that graphed. And then he would need to graph 3x on the interval of 2 and 5. So that was his mistake on that graph. He made several mistakes. All right, last one. They give us, use the piecewise defined function to fill in the blanks. So here's what they give to me. F of x equals 4, so that's a horizontal line. When x is between negative 4 and negative 2, not included. 2x minus 4 when x is between negative 1 and 2, again, not included. 3x when x is between negative 2 and 5, negative 2 is the only number included. So it says the domain of what is used when graphing the function f of x equals 2x minus 4. This one, this is the one that we're talking about. The domain is between negative 1 and 2, neither are included, so parentheses, negative 1 to 2. The equation what is used to find f of 4 equals 12. Okay, so I come up here, let's see if I can erase that for you. Come up here and look at where is 4 in one of these domains. Okay, so 4 is not up here in this domain. 4 is not in this one. It is in this domain. So I would have to plug in 3 times 4 to get 12. So the equation 3x is used to find f of 4 equals 12. I hope this helps to clarify some of the issues we were having with sections 1.1, 1.2, and 1.3. I want you to go back into Envision, work on some more of those assignments that you have not yet completed, if you have not completed them and submitted them. That last worksheet that I gave to you over 1.3, the piecewise, hopefully this helps clarify some of that. I have put together a quiz covering all of this, sections 1.1, 1.2, and 1.3. So once we feel more comfortable with that, next week, next Tuesday, hopefully I will be there, we will take that quiz over these first 3 sections. try to make up for our last quiz over 1-2. I hope this helps. If you have any questions, please do not hesitate to email me. I miss you all and hope to see you soon.